Okay, I wanted to take a minute to go over problem 4.18. A number of people misunderstood this problem, so I want to go over it real quick in this video. So a researcher is interested in learning about the exploratory behavior of a particular strain of rats. He has taken 20 such rats and deposited a rat individually on the bottom of a circular box. The floor of the box has been laid off with a grid, and the number of squares into which each rat stepped in a 30-second interval is recorded. This is a commonly used index of exploratory behavior called the open field test. The following data are the number of squares for each of the 20 rats. Now, what a few people did was mistakenly took this row as the data, but this is not the data. This row right here is not the data. This is simply the rat's number. This is like the rat's name in a sense. And so if you took and you created an axis numbered 1 through 20, then what you were really doing is putting the positions on the axis that corresponded to the rat's names, which doesn't really make sense. This row, though, is the data. Now, one way to kind of help yourself keep this straight is to actually define a variable every time you make a graph. Because when you think through the process of what the variable is, then I think it'll help you figure out what axis to use, for example, for the horizontal axis. Because again, if you follow the methodology of always labeling your axis with a well-defined variable, then it'll really help you keep all this straight. So x will be defined as the number of squares a particular rat steps in. Now see, with a clearly articulated variable, I can come down and start to think about how I'm going to label and scale my axis. Let's see, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then maybe I'll put one more for 12. So let's see. And I guess technically I could have a 0 here, even though I don't really have a data value that corresponds to 0. But again, this is just how I'm going to scale the axis. And maybe I'll go one more to 12. Okay, so now rat 1 stepped on 3 squares, so I would put an X here. Rat 2 stepped on 2 squares. 3 stepped on 4. 4 also stepped on 4. Rat 5 stepped on 6. Rat 6 stepped on 5. Rat 7 stepped on 6. Rat 8 stepped on 7. Rat 9 stepped on 7. Rat 10 stepped on 6. Rat 11 stepped on 8. Rat 12 also stepped on 8. Rat 13 stepped on 7. Rat 14 stepped on 9. Rat 15 stepped on 7. Rat 16 stepped on 8. Rat 17 stepped on 9, so did 18. Rat 19 stepped on 11, and rat 20 stepped on 10. So this would be the appropriate frequency plot for this particular data set. Now, part B asks us to state an appropriate description for what the plot tells you about the open field test responses for these rats. And so what can we say about this? Well, to me, the distribution looks mound-shaped, like, or instead of like, maybe consistent with data sampled from a normally distributed population. And I might also say that there are no apparent outliers. Oops, outliers. Okay, so anyway, quick video just to go over this homework problem, and hopefully this will clarify how this graph, mainly it was the graph. Of course, if you drew the graph wrong, then part B was not correct either. So anyhow, okay, so that's it for this video.